Assalamualaikum and good day to my panelists and viewers. My name is Nur Daini binti Rosrizan and I'm from University Malaysia Perlis. I will be presenting my research paper by the title of Comparison Study of UHF Sensor Modeling based on fourth order Hilbert Fractal category for partial discharge detections in power transformer. This is the several topic that I will cover today. For the introduction parts, PD is an electrical discharge or spark that breaches a small portion of the insulations. PD is very common, known as failure and breakdown due to the high voltage in equipments. PD can occur in any locations where the local electrical field strength is sufficient to break down the portions of the dielectric material. There were several causes of PD, such as aging of the equipments, environments, mechanical damage, and also during the manufacturing defects. Therefore, in this paper, we have presenting an array with partial discharge for order Hilbert Fractal UHF sensor for the PD detections in power transformer. Why we use this UHF PD detection? Because of their strong anti-interference ability over the traditional techniques. For the methodology parts, after we have identified the UHF PD frequency, which is from 0.3 to 3 GHz, then we will start to calculate the parameter that we need to design the UHF sensor. And after the parameter that we need meet the requirements, then we will start to design and simulate the UHF sensor. And for the last part is we will analyze the simulation result during the PD measurements. This is the Hilbert Fractal UHF sensor with different size and number of order. This formula we have been used to design this UHF sensor. And this Hilbert Fractal is from first order until the fourth order. For modeling an array for order Hilbert Fractal UHF sensor with transmission lines, there was three main parts during designing this UHF sensor, where the first layer is copper conductor, the second layer is FR4 for the boards, and the third layer is for the copper conductor for the ground plane. And this is the final parameter for the UHF PD sensor. For the transmission lines, this is the formula that we have been used to design these transmission lines, where the Z1 is a feed line of the 70.71 ohms that are utilized for the perfect matchings between the 100 ohms and 50 ohms lines. For the partial ground methods, reductions of the ground planes is to enhance the antenna characteristics, such as to increase the efficiency, improve the impedance matchings, and the focus of the paper is to increase the bandwidth of the UHF antenna by using these partial ground techniques. And we can see that this is how the partial ground look like from the back view of the UHF sensor. For the simulation result, this paper is focused on three simulation results, which are reflection coefficients as parameter, voltage standing wave ratio VSWR, and the last one is 2D radiator pattern. For the S parameter, the value of the reflection coefficients over the operating frequency range should lower than negative 10 dB. In other words, if 100% of power delivered to the sensor, at least 90% of the sensor can receive. From this comparison of three simulation results, we can see that an array with partial ground for order Hilbert Fractal sensor can operate from the lowest resonating frequency, which are from 0.6 GHz with the reflection coefficient less than negative 10 dB. For 2D radiation patterns, this simulation result represent the capability of the sensor in receiving signal in certain directions. And from the radiation pattern shapes, it can prove that the most of energy is emitted in the interest of PD directions. And this is the radiation patterns of the three sensors. The last one is VSWR result. According to the antenna theory, the smaller the value VSWR, the better the performance of the sensor. The best sensor is with minimum value VSWR is 1. Means no power reflected from the sensor. And from the simulation result, we can see that an array with partial ground for order Hilbert fractal sensor has a minimum value VSWR compared with these two sensors. And that's all from me. Thank you.